All right, so this is from the volumes of integration 2, I think, around the x and the y. Number 5 here asks us to show this integral. That's a standard one. We've done that one before in class. So basically, we're going to use this property that cos 2x is 1 minus 2 sine squared. And then we solve that for sine squared, and we get 1/2 minus cos 2x over 2 is sine squared. So now what we're actually integrating is 1/2 minus cos 2x over 2 with respect to x. And that's much easier. So that gives us x over 2 minus sine 2x over 2 times 2, which is 4, plus our constant. Okay, that's part A. Now, part B. We're going to use that result, hence means we have to use the result we just found to calculate the volume around y equals 2 sine x, which looks like this. And we want this going around like this from 0 to pi. Okay? So from 0 to pi, I'm going to throw the pi out front. My y function is 2 sine x. I'm squaring that from my formula booklet. Okay, 2 squared is 4. Let's pull that out. 4 pi, the integral from 0 to pi sine squared. So now you see why they asked you to do part A. Okay, we can jump right to using this result, evaluating it at 0 and pi. So keep the 4 pi out front, open a set of brackets. You have x over 2 minus sine 2x over 4, and that is evaluated at 0 and pi. We can ignore the constant of integration now. Okay, pi comes in and you'll have pi over 2. Keep the 4 pi out front. And then minus sine of 0, which is 0. And then you put the subtracting 0 into it. 0 over 2 just goes away. 0 into sine of 2x also goes away because that's also sine of 2 times 0, which is sine of 0, which also goes away. And this big mess just turns into 2 pi squared, and then whatever your units are. Okay, so just check, once you put in pi, 2 pi again gives 0, so you're subtracting 0, not a problem. 0 goes in, you have 0. 0 goes into this, you also get 0, so all that other stuff drops out. Good.